Hello, geometry. Today we're going to start our review over systems of linear equations. You should have done this again in the middle of algebra last year. So a reminder, a system of equations is just one or more, or two or more, sorry, linear equations. Linear, you can tell an equation is linear if it's just the x and the y. There's no x squared, there's no y to the third, there's no other power. You just have an x and a y. So a solution to a system of linear equations is an ordered pair, so a point, that makes both equations true. So it has to be true for both. And therefore, if it's for both equations, then the system would be true. So practicing that piece of it, determine if each ordered pair is a solution to the system. So example one, here's our ordered pair, and we have this system, and we're going to take our numbers. So if you remember, x is always first, y is always second. So in this ordered pair, I have x equals 1 and y equals 2. Okay, you could even write that off to the side if that was helpful. Okay, what we're going to do is take each of these equations and plug in the x and the y. And again, I am going to use parentheses when I do that. So 2 times 1 minus 3 times 2 is equal to negative 4. And then we're going to check to see if that is actually a true statement. So you can use a calculator, but 2 times 1 is 2, and then minus the 6, that's going to be 6. So that total would be a negative 4. That is equal to negative 4. So that point checks out for the first equation. However, you do have to check it on the second equation as well. So maybe I'll do this one in green, and I did this one in blue. So on the second equation, I have y, and then negative 2x plus 4. And then on this side is obviously just 2. Here I have negative 2 plus 4, which is also 2. So it checks out for the second equation. So our answer here would be yes, that is a solution to the system. Checks out in both equations. Okay, so pause the video and try yourself number 2. Okay, welcome back. So this is going to be x and this is going to be y. So x is 7 and y is 6. And again, you're going to plug into the same guys here. So 2 times, this case 7, minus 3 times 6 equals negative 4. Again, you could use a calculator, but this is 14 minus 18. So that's negative 4, which is negative 4. Okay, that one checks out. However, you do have to check both equations. So I have a 6. Y equals, and then negative 2 times 7 plus 4. So on the left side, this is obviously just 6. And then this is negative 14 plus 4, which is a negative, 10. So that is not true. So doesn't work for the second equation. Therefore, my answer here is no. That point is not a solution to the system because it does not work here. Okay, next. So we're going to talk about how to solve a system using the substitution method. Okay, and this is generally people's favorite method. But substitution, so example 1, this is just a basic one. So here we are given y is equal to 2. Well, that is just, if you remember your graphing, that is just a horizontal line at 2. But when you have the y all by itself already, you're going to take whatever it is equal to, and you are going to replace or substitute into the other equation. So here I would get 2x minus 6 times 2 is equal to 10. What that creates is it creates an equation where I only have one variable, and that is something I can actually solve. Because what I started with was an equation with two variables. And I don't know how to get the numbers if I have two variables. Okay, so I plug in the 2 here, and then I'm going to start simplifying. So that's minus 12, and then add 12 to both sides. You get 2x is equal to 22, and then divide both sides by 2, and you get x equals 11. And then we started out with the y equals 2, so that is the other part of the solution, and then you can write your answer as a coordinate point. X equals 11, y equals 2. Okay, example 2. So this one's slightly harder because we have a variable by itself, which is the goal to start. But this time I have an algebraic expression. So I am going to take whatever is on the left or on the right side here, and then this is x equals y plus 5. So I'm going to replace y plus 5 for x. So what that equation would be is 5 plus y. That is the x value here. I'll just circle it even so you see it. And then I recopy the rest of the equation. So I replaced the x with this circled expression in the second equation. Okay, so now I have an equation that has all one variable, and then you can solve from there. Okay, so combine like terms, subtract the 5. So I end up with 2y is equal to 6. Divide both sides by 2, I get y equals 3. Okay, and then this is the last step that we didn't have to do on the first example, but I need to use this y equals 3 and figure out x. So my last step is you're going to plug into that original equation y equals 3. So now I'm going to get x is equal to 5 plus 3, and therefore x is equal to 8. Okay, so my final point would be 8, comma 3. Again, x equals 8, y equals 3, and again, that will work for both equations. Okay, so pause for a second and try number 3 on your own. Okay, welcome back. So I have a y equals a y variable all by itself. I'm going to take this expression and I'm going to replace y in the other equation. So again, we have 6x plus 4, and then that circled expression is negative 3x, and that equals 12. Okay, again, we have an equation with only x's. So then I'm going to simplify. 4 times a negative 3 is negative 12. Combine like terms. So I have 6x minus 12x, which is a negative 6x. And then divide by negative 6. And I get x is equal to, that's a negative, x is equal to a negative 2. Okay, again, last step here, you take that negative 2x, you plug it into the circled part. Okay, so my last step would be y is equal to negative 3 times a negative 2, which is a positive 6. And then my final answer in coordinate point form would be negative 2, comma 6. Okay, last one. So this is the hardest version. And the reason being is that I don't have x or y by itself. So if you look at number 2, example 2, x is by itself, so I take that expression, substitute. Example 3, y is by itself, so I take that expression and I substitute. Here I don't have that. So you have to look for something to move around. So you look for, first of all, a y or an x with 1 as a coefficient or just no number in front. So I'm just looking at this y right here. It looks pretty good. It's just a plain old y. So what I'm going to do is add 2x to both sides. And then I end up with an equation y is equal to, And you can say 8 plus 2x, but generally we put the x first. So that first equation is now y equals 2x plus 8. So I have this expression that I can substitute in for, oops, wrong one. It's y equals, so you want to substitute in for y. So you substitute that in for y right there. Okay, so writing the second equation, I write 2x plus, and then that circled part is 2x plus 8, this part right here, and then equals 4. So I'm taking this second equation, rewriting it with the 2x plus 8 in there. Okay, and then I'm going to combine like terms, and then solve for x. So I get 4x here. I don't know why I wrote the x like that. Let's try that again. So 4, gosh, this is a 4x. These cancel. I'm like getting ahead of myself. So 4x, and then over here 4 minus 8 is negative 4. And then when you divide by 4, you get x equals negative 1. And again, last step, you take that negative 1 and you plug it in, and you can plug it into any equation. So what the easiest place to plug it in is actually this guy, because the y is already by itself. Okay, so I'm going to get y is equal to 2 times negative 1 plus 8, and then therefore y is equal to, so this is negative 2 plus 8, so that's going to be 6. And then my final answer is negative 1 comma 6. Okay, so what you are going to do now, and you can replay this, any of these parts of the videos to look at it and the process again. But what you are going to do now is on your own piece of paper, you're going to split it up like we did in class. You're going to draw a vertical line down the middle, horizontal line down the middle, or in the middle, making the 4 sections. And then you're going to complete these 4 problems. So you may need to pause to write these 2 problems down, and then pause, and then write down number 7 and number 8. I have also included all of the answers here so you know if you're doing it correctly. Okay, so please do 5, 6, 7, and 8 on your own paper, and I will see you next time.